Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's video, we'll be focusing on the concept of functions. So now when we look at the syllabus, topic 2, it's about algebra and functions falls into the category of algebra. Now, what exactly is there in function? Understand functions, the concept of domain and range, and use function notation. Example includes such, such, and such. Understand and find inverse function. Example, fx is this, gx is this, find f of gx, that is about the composite function. S defined by g fx is g of fx. Give your answer as fraction in its simplest form. Candidates are not expected to find the domains and ranges of composite. That's not part of the syllabus, but basic domain, basic range, I'll just talk about it. Yes, the question is about that. The concept may include mapping diagrams. So let's get started with the basic idea of a function. Now, when we have an equation, let's say y is equals to x plus 1. If I plug in a value of 0, therefore y is 0 plus 1, which becomes 1. So now if I replace y with fx, that becomes a function. Fx is x plus 1. If I plug in a value of 0, therefore 0 plus 1 becomes 1. That means if I draw a mapping diagram, and let me draw two circles, and these are the values of x, and these are the values of fx, and what is the function that transforms that? So 0 is becoming 1. That means the work of this function means work. The work of this function is take any value of x and add 1 to it. So 0 becomes 1, 11 would become 12, minus 1 would become 0, and so on. This is called a mapping diagram. A function could be of different types. So it could be a linear function. It could be a quadratic function. We can talk about a reciprocal function. We can talk about a cubic function. And we can talk about an exponential function. So these are the different functions that we have already sketched. So check out the videos of all of these related to sketches, and they are applicable for O-level, AS level, and A-level. Of course, the basic idea is from the perspective of O-level, but equally good for AS, equally good for A-level. And in AS, it's called P1. In A-level, it's called P3, and in O-level, that's 4024 or 0580 of the Igcse. So now that is the basic idea of function. The input value, the x value, gives us the output value, the y value. The input value, the x value, is known as domain, and the y value is known as range. For example, I can work over here. Let me write fx is equals to x plus 5. And let me write the domain of x lying between 0 and 4. That means if I draw up a table, so let me draw a small table over here, and then I'll be talking about a quadratic also. If I draw up a small table, and let me write over here x and y, let me choose some integer values, that is 0, that is 1, that is 2, that is 3, that is 4, and I'm adding 5 to it. So 0 becomes 5, 1 becomes 6, 2 becomes 7, and 3 becomes 8, and 4 becomes 9. So therefore, the range of this function, what is the lowest value? The lowest value is 5. What is the highest value? That is 9. So therefore, the range of fx, the function, should be between the lowest and the highest. So it should be lesser than or equal to 9, greater than or equal to 5. That is the range for this corresponding domain. Now let me choose another function, gx is equals to x squared. And let me choose values of x between 0 and 6. So if I choose between 0 and 6, so I can draw up a table, or let me draw a diagram over here. So that's a thick, what you call grid. Let me choose a red color marker. Let me draw a graph like this. So basically, the graph of y is equals to x squared goes like this and then goes like this, something like this. And that's not a very symmetric graph. So let me draw it a bit symmetric. Okay, I think that one is better. And we know that if I focus my attention from 0 till 6, so this is 0, and let's say it's 6 up till here. So if I plug in 0, I'll get a 0. The values are increasing. What is 6 going to give me? 6 is going to give me 36. So first of all, let me erase this part of the graph. So using a precision eraser, let me erase this part because it's not needed. So what is needed? Let me just cut this thing. Let me also remove this thing. If it's not needed, just remove it. So now what is the range over here? So the range over here is the greatest value is 36 and the least value is 0. That is the basic idea. Let me draw another function. Let's say if x is equals to 2 raised to power of x, x lies between 0 and 4. F of 0 is 2 raised to power of 0, which comes out to be 1. F of 4 is 2 raised to power of 4, which is 16. There are no turning points in between. What if there is a turning point? I'll also plug that in a short while. So now if I draw it like this, let me draw the graph of y is equals to 2 raised to power of x. So my focus is from this point. So this is 0 plugging in and giving me 1. And let's say, let me move the y-axis a bit up like this. Let me move the whole ground down, something like this. And let's say this is till 4. So it's not drawn to scale. So this is 4. This corresponding y value is 16. This value is 1. So therefore, the range of this function lies between 1 and 16. That's how the graph is drawn. What about hx? That is x squared, and x lies between -2 and +3. Now, if I plug in -2, I get a 4. If I plug in +3, I get a 9. But there is something special. That something special is the concept of turning point. So let me draw the grid over here. So let me draw the x-axis and the y-axis. And let me draw this curve like this. And let me draw this portion like this. So now if I focus on this, this -2 is giving me 4. This +3 is giving me 9. There is also this point 0, 0. So what is the highest y value? 9. The lowest y value from calculation is 4 because we did not take into consideration the 0 in between. So 0 is the lowest y value. So that's just a wild card question that might come because it's more into A levels. But since they are focusing on turning point, so I feel it worthwhile mentioning this. So therefore, the lowest y value is 0, the highest y value is 9, and that is the range. So that is the concept of domain and range. Let's talk about inverse. We can write, let y is equals to fx. Therefore, f inverse y equals to x. What does this mean? I can make you understand this thing by using a very, very simple example. So let's say there is a function fx, and fx is x plus 3. What is the function of this function? It takes any value of x and adds a 3 to it. So what should be the inverse? The inverse should be opposite of this order, that is -3. Now, let me write over here, add, subtract. They are inverse of one another. multiply, divide, inverse of one another, square and square root, inverse of one another, cube and cube root, inverse of one another. So if I want to find this, that's how you do it. What it says is that in the original function, if you plug in this value, you get the output. If you plug the output in the inverse, you will recover back the input. And we will just check. So let y is equals to x plus 3, y minus 3 is x. But what is x equals to? But x equals to f inverse y. Since we have a habit of writing everything in terms of x, therefore f inverse x is x minus 3. So now let me draw a mapping diagram over here. So let me draw two circles or ovals, doesn't make a difference. And let me write over here x, hold for a second. So let me write over here x, and this is y. So now the function, let me plug in f of 5. So that would be 5 plus 3 would be 8. So this is giving me 8. Which function is such that I plug in 8, I'll get back 3. So 3 is giving me 8. So that should be the inverse. So now we know that inverse function is x minus 3. So inverse function is x minus 3. Therefore, f inverse of 8 should be 8 minus 3, which is 5, which makes perfect sense. So 3 becoming 8 using fx, 8 becoming 3 back again using the inverse. So that is the basic idea over here. Let me do some more examples. Let's say fx is equals to 2x plus 3 divided by 4. Let y is equals to 2x plus 3 over 4. 4y is equals to 2x plus 3. 4y minus 3 is 2x. Go very easy. 4y minus 3 divided by 2 is equals to x. But what is x? So let me write over here, let y is equals to fx. Therefore, f inverse y is equals to x. So x is f inverse y. In the end, write everything in terms of x. F inverse x is 4x minus 3 over 2. That is how you find this thing. Let's talk about composite. Composite means function of a function. Function of a function. So now let's say there is a function fx that is x plus 1. And there is a function gx which is x cubed. Let me choose a value. Let x is equals to 1. Let me evaluate f of 1. This comes out to be 2. Let me evaluate g of 2. So g of 2 is 2 cubed, which comes out to be 8. Now let me draw those 3 circles over here. The first one, the second one, and the third one. There is a value of x, 1. 1 is becoming 2. 2 is becoming 8. 1 is becoming 2 because of fx. 2 is becoming 8 because of gx. Is there any single function which will take this 1 and directly convert it into 8? That is the concept over here. So now, how do you do this? You either evaluate f of gx or you either evaluate f of gx. Which is the correct one? We will soon know. So f of gx means plug gx in place of x. What is fx? X plus 1. So this is gx plus 1, which is x cubed plus 1. And g of fx means plug in fx inside gx. Gx is x cubed, so that is fx the whole thing cube, which is x plus 1 the whole thing cube. Now let me evaluate f of g of 1, which is 1 cube plus 1, which is 2. Let me evaluate g of f of 1, which is 1 plus 1 whole cube, which is 2 cube, which is 8. This is giving me the wrong answer. This is giving me the correct answer. That means first f, then g. That is g of fx. So let me write the statement over here. That is first f and then g. That is the same thing as g of fx, because we are going in this direction, x going inside f and the result going inside g. That is how this thing is obtained. That is the basic meaning of a function, composite function. Now, background knowledge. What do we need for this? We need the concept of linear function. We need the concept of quadratic, cubic, reciprocal, and exponential. So these 5 functions that we talked about earlier in relation to sketching can also be talked about with context of these things. So let's do some past paper questions. Now, let's look at the first question. That is, first of all, where is the question from? The question is from the specimen practice paper. There were 2 practice paper and 2 specimen and 1 practice paper. So 3 paper 1s, 3 paper 2s, and that is the videos that I've made, and you can check it out on my channel. So fx is this, gx is this, hx is this. First part. And let me highlight in 3 colors so I know exactly what I am doing. That is fx. This is fx. This is gx. This is hx. The first find is about h, and then I don't mix it up. The second part is about fx. The third part is about f and g both. And the fourth part is also about f and g both. And then the last part is about fx. Fx, I think it's in red color. So that is this thing. So there are 5 different things. Let's work it out. First of all, the first thing is very simple, h of 3. So first write hx is 4 power x. Therefore, h of 3 is 4 power 3. Cube of 4 is 64. So write 64. The domain of f is this. By the way, this is a linear function. This is a quadratic. This is a power or exponential function. The domain of fx is this. So what is fx? First of all, that is 3x plus 2. So in a straight line, there is no turning point. All you need to do is to plug in -4. So 3 into -4, -12 plus 2, that is -10. And f of 4, 3 4s are 12. 12 plus 2 is 14. Highest value is 14. Lowest value is 10, negative. So this is -10. This is plus 14. That's the range. Find f of g of 1. First evaluate g of 1. Gx is quadratic, x squared plus 1, which is 1 squared plus 1, which is 2. Then f of g of 1 basically means f of 2. That is 3 into 2, 6 plus 2. That comes out to be 8. Evaluate g of fx in this form. First of all, let me write gx. I think it's x squared plus 1. Let me write fx. That is 3x plus 2. No harm in checking. 3x plus 2, x squared plus 1. Perfect. G of fx. So g of fx means fx inside gx. That is fx, the whole thing squared plus 1, which is 3x plus 2, the whole thing squared plus 1, which is 9x squared. 2 into 3 is 6. 6 plus 6 is 12x plus 4 plus 1. That is 9x squared plus 12x plus 5. 3 marks for this. Find f inverse x, something very traditional. Let y is equals to fx. Therefore, f inverse y is equals to x. Yes, you should write it down. Therefore, y is equals to fx is 3x plus 2. Y minus 2 over 3 is x. X is f inverse y. Therefore, they are writing in terms of x. That is x minus 2 over 3. So that is how this particular question is done and dusted. Another question. Where is it from? This is again from the specimen paper 1. Fx is linear. So let me highlight it once again. Fx is linear, gx is quadratic, and hx again is linear. So first of all, they are asking about f, they are asking about g and f, they are asking about h, and there are 3 parts to this. So coming back to this, first of all, f of 3, very basic, f of 3, 5 into 3, 15, 15 plus 2 is 17. Do not forget to write over here. G of fx, g of fx, that means gx is x squared minus 2, so that should be fx. whole square minus 2, that is 5x plus 2 whole square minus 2. You have to convert it in this form. That is 25x squared plus 20x plus 4 minus 2. That is 25x squared plus 20x plus 2. 3 of h of fx. First evaluate h of fx. That means fx inside hx. So 7 minus x. 7 minus x means 7 minus fx. That is 7 minus, use brackets, 5x plus 2. So this is 5x plus 2. So 7 minus 2 is 5. That is 5 minus 5x. And then 3 of hfx. 5 minus 5x equals to negative 1. 3 is equals to negative 1. 5 minus 5x. Go very slow. That is minus 5 plus 5x is 3. Take 5 on the other side. 8 is equals to 5x. X is 8 over 5 or 1 whole 3 over 5. So 1 whole 3 over 5. I've written the answer like this. Similar questions over here. Nothing special. This is f of x minus 6. Just plug in x minus 6 over here. Nothing special. Where is fx? 2x squared minus 3x. So this is fx is equals to 2x squared minus 3x. I can even write this thing as x 2x minus 3. First simplify, then plug in f bracket x minus 6. That is x minus 6. And this is 2 bracket x minus 6 minus 3. This is x minus 6. This is 2x minus 12 minus 3. This is x minus 6. Let me write 6 properly. Make sure the examiner can read it. 2x minus 15, x into 2x, 2x squared, negative 15x, negative 12x. 6 into 15 is 90. So therefore, 2x squared minus 27x plus 90. Do check for any mistakes. That could be done in a hurry. Use the quadratic formula, and this is a paper 2 question. So I'll skip it because right now we are focusing on paper 1. Otherwise, just use the quadratic formula. This question, let me do it. Again, this first one is quadratic. The second one is linear. The third one is also linear. First thing, f of negative 3. That is negative 3 whole square, which is positive 9, which is positive 9. G inverse of x. Let y is equals to gx. It's no more fx. It is gx. Therefore, G inverse y is equals to x. Y is equals to x plus 5 over 2. 2y minus 5 is x, but x is G inverse y. So therefore, G inverse x is 2x minus 5. H inverse of 63. Now that's a very nice question. H inverse of 63. What does it mean? Let me give you a small example to illustrate this idea. And let me add a page over here. What is this property that they are talking about? Now, let's say I have a function fx that is x plus 3. Let me plug in 5. So f of 5 is 5 plus 3, which is 8. Let me write the inverse, which is very simple, x minus 3. And let me write f inverse of 8, that will be 8 minus 3, which is 5. So now, if I write f of f inverse of 8, what will I get? Think about it. F inverse of 8 is over here 5. So this becomes f of 5. And f of 5 is over here, which is 8. So basically, whatever is written, you will get this. So remember this thing, if we take composite of 2 functions which are inverse of one another, so f of f inverse x comes out to be x. Just use this result. F inverse of fx will also come out to be x. Let me show you this. Fx is x plus 3. F inverse x is x minus 3. F of f inverse x, that is plug in inverse in place of x, f inverse x plus 3, which is x minus 3 plus 3. What am I left with? X. Similarly, f inverse of fx, that is fx minus 3. What is fx? X plus 3. Let me write x properly. So this is x plus 3 minus 3. What do you get? X. So hard and fast rule that you should remember that f of fx, f of f inverse x, f of f inverse x is equals to x, f inverse of fx also equals to x. So therefore, h of h inverse 63 is simply 63. And this is g of f of x. So now this is for 3 marks. Let's evaluate g of fx. Gx is x plus 5 over 2. Gx is half x plus 5. That's a neater way of writing. G of fx is half bracket fx plus 5. What is fx? Fx is x squared. So this is half bracket x squared plus 5. Now equate it to 63. So half x squared plus 5 is equals to 63. This is 126. X squared plus 5 is 126. And therefore, x squared is 126 minus 5 is 121. Therefore, x is plus minus. But have they given any domains? Yeah, x is greater than 0. That means x is positive. So x is positive 11 only. That is the answer. So this is 11 over here. A very, very starry question. So that is the basic idea. Nothing special. On the Excel sketch, the graph of y is equals to gx. What is gx? X squared minus 16. We have done in quadratic. So just a quick overview. X squared minus 16 can be written as x plus 4, x minus 4. And we are using the factorized form, the roots of the equation, that is negative 4 and plus 4. And what else are they asking? The coefficient of x squared is positive. That means it's a happy phase graph. So just make sure that it looks symmetrical and beautiful like this. And the graph is over here. That is plus 4. That is minus 4. That's how the graph is drawn. So this I have drawn on the basis of factorized form. X plus 4, x minus 4. Now let me do one other thing over here. Let me make it thinner. And let me also draw it this way. So I can draw the graph of y is equals to x squared and then shift it 16 units down. So I have to just go down a bit. Okay, that's good enough. And then shift 16 units down like this. So that's another way. So this blue one, that is very thick. So over here, this one, this is y is equals to x squared. This one, y is equals to x squared minus 16. The turning point is 0, 0. The turning point is 0 and negative 16. So this is method 2 of drawing the graph. This is method 1 of drawing the graph. So a quick overview of quadratics. If you need more details, check out the video. And I think that's about it. So now this concept of functions related to basics, related to domain and range, related to linear, quadratic, cubic, exponential, and reciprocal, it's all done. And we talked about inverse function. We talked about this property, which a lot of people don't emphasize on. F of f inverse x is x. F inverse of fx is equals to x. And then we talk about composite functions in general, and we talked about a little bit of sketching. So that's all from Mathematics with Shahab Yaqub. Take care, everyone.